In this week's edition of the Embedded Insiders, Brandon and Rich discuss all of the new programming languages that have entered the embedded universe. This is in large part due to the convergence that IoT has created between IT and embedded developers. Are we getting to the point where you won't use C language anymore, or is it here to stay for good? Niall Cooling, the CEO of Phoebus Limited, continues the conversation about embedded programming languages by weighing the advantages of languages like C against newer iterations of C++ and upstart alternatives like Rust. Where do all of these fit into the software engineering toolbox? And what are the implications of this low-level embedded programming on overall system cost? Later, technology editor Perry Cohen interviews Chris Ramel, Executive Vice President of VDC Research, in a new segment, Tech Market Madness, Analyst Insights for Engineers. Chris reveals just how many engineers are currently using C, C++, Python, Java, and other languages based on data from his company's annual Voice of the IoT Engineer report. According to the study, more than 50% of developers have used C in past projects, while only 44.6% are using it currently, and just 38.3% plan to leverage it in future designs. Meanwhile, the use of Python and Rust continues to rise.
Welcome to another edition of the Embedded Insiders. I'm Brandon Lewis here with I don't want you to be Darth Vader this time. We've got to figure out somebody else that you are of embedded.
Can I just be me?
I guess. Fine. This
The
time,
world's best dad?
You even got a coffee cup that says that.
I'm the only one in the world with that coffee cup.
Right. How you doing, Rich? Rich Nass of Embedded Computing Design here.
I'm doing good. Thank you very much. Speaking of dad issues, I was with my kids not too long ago, and we had this discussion, which I love to have. If you could have lunch with any one person, dead or alive, who would it be? So I'll pose that question to you, Brandon. If you could have lunch with any one person, dead or alive, who would it be?
That's interesting. Part of me wants to say Elon Musk. Part of me wants to say Einstein or like Winston Churchill. But I think I'm going to go with Neil deGrasse Tyson. I think I'll go with him.
Okay. All right. I could live with that.
How about you?
Mine is Ben Franklin. Why is that funny? He's an electrical engineer. He just discovered electricity in a very similar way that I discovered electricity the other day. But he's got all these awesome sayings. I think that would be so much fun.
The reason I'm laughing is I'm just trying to imagine like you sitting at a table at a restaurant with Ben Franklin with his frilly neckerchief and glasses and stringy hair.
Well, we're not going to Hooters. I mean, we would go someplace respectable.
No, I didn't even if you were someplace respectable, imagine, what is he? Because he got his kite, like it's all burnt up kite there too. Like,
well, with all the Corona stuff, you have to eat outside, so his kite is acceptable.
Okay. Oh, just tie it to the back of his chair.
All right. What are we doing this week?
Well, over the course of the last, 5-10 years, there have been a bunch of new programming languages that have entered the embedded universe. That's partially because, like we talk about a lot, IoT has sort of converged that world between the IT app embedded developers. So those types of developers that are new to IoT and embedded systems still want to use the languages they're familiar with, Python, Java, JavaScript. But that being said, C and the C variations have been around and embedded almost since the beginning, and they're so well entrenched. I'm just wondering at what point, if ever, the switch is going to flip and we're just going to be done with C. Like, I subscribed to a bunch of channels on Quora, and there was a question that came through the other day. It said, why is C still even in use, although we have C++? Like, why?
Well, do you know the installed base of C? I mean, it's just ridiculously big. There's so much assembly out there that it isn't going to go away ever, probably.
I agree with that, but don't you think at some point people are just going to say, screw this, we're starting from the ground up and we're building everything in Python?
Well, that's until the next new thing comes along. And one of the next new things that didn't really ever fly, which I thought was pretty cool, was it was a graphical language where you literally cut and paste images that represented functions. So you didn't have to know the language at all. Like if you wanted a motor to do something, you dragged your motor on with your specs, and it just wrote everything for you in the back end, which was likely assembly.
Why do you think that didn't work? Do you think it was too bloated? It didn't give you enough control over those low-level bits and bytes?
Yeah, I think you hit it right in the head. You know how engineers are, especially on the software side. They need to understand what's happening below the curtain, behind the curtain.
One of the reasons that this is interesting is that I have somewhat foretold that at some point in the next 10, 20 years.
Does that mean predicted?
Yes, yes, it does.
Okay, just making sure. Somewhat foretold. Okay.
Rich Nass, human thesaurus, everybody.
Sorry.
So I've somewhat foretold that in the next 10 to 20 years, embedded engineering as we know it will no longer exist. And the reason for that is that with all of these IoT type developers that I mentioned a little bit earlier, they don't care what the endpoint is. They're used to cloud native, ultra portable containers. Like I write once, run it anywhere. So if that's the case, an embedded device is just basically like an extension of your data center network resources that's just flung out way to the far edge. And guess what? Now we've got 5G that's spreading all these compute resources all around anyway. So why do we even need embedded engineering, and why do we need C? We'll have a couple of companies who just build these embedded boxes, but I'm just really deploying all of my application software that I've written out onto that system. And the only reason that you'd need C or these lower level languages is just to make sure that the thing is up and running and performing its single function or couple of functions.
What's your time frame of your foretoldness?
10 to 20 years.
10 to 20 years. Okay, well, I probably could have found somebody 10 or 20 years ago who would have said the same thing, and it hasn't happened yet. But I would very much like to get somebody who lives in this space to answer that question.
Now, the insiders are joined by Niall Cooling, the CEO of Phoebus Limited.
Today's developers do not want to know anything about the bits and bytes of the hardware that they're coding for. The furthest thing from their mind is wanting to program in a language like C. They want to use anything that abstracts away whatever their software is going to be running on. What does that mean for the future of C? Obviously, C is installed everywhere, but does it have a shelf life?
I mean, it's one of these bizarre things that we keep saying this, and I think every decade we come around and we have the same discussion about, when is the lifetime of C going to end? And certainly at the moment, there's no indication it's going away anytime soon. You talk about languages like the Pythons and the Javas, etc., and there's been some great development in areas like MicroPython. We're seeing that being used in a lot of systems that are embedded but not real time as such, because, as you say, you've got guys coming out of college and they've got that sort of experience. But I think it's the fact that we call it right shifting, is we keep putting processes into things that we wouldn't have imagined even only a few years ago. Your toothbrush, and obviously you think about things like Dyson vacuum cleaners, etc. Why would you be doing that? And yet we keep finding new ways to put process in. And those early ones, cost is a factor. And while people are still using things like PIX and the Cortex M0s, which are so cheap and have such a small footprint, the difficulty there is if bill of materials dominates, to put things like Python on there and even MicroPython, that's still a factor. That's still going to be a factor. So you've got the performance angle, you've got the memory angle as such, the cost angle as well. And C just ticks those boxes at the moment. And it still ticks those boxes. You look at modern C++ and C++ 17, you look at 20, that's actually much closer to Python in many ways. It's quite weird when we teach it. that people are surprised the stuff you can now do in modern C++, that it just looks almost like Python, you know, with auto type deduction, etc., and something called structure bindings. But it still comes down to performance. And we see in the server systems, people have moved away from even languages like Go and gone to other languages like C++ because they can't get that raw performance out of the language. So the Pythons, the JavaScripts, we've got to understand they're an interpreted language. And once you've got an interpreted model in there and the memory management is done for you and you've got garbage collection, I mean, there's been great improvements, but there's still going to be that raw performance issue. The only language that excites me at the moment is Rust. That's the first one I've seen in decades that has the potential to be I don't think it will supplant C, but I think it will be the real third player in that market. First, it's a compiled language. So from a raw memory model, it's identical to C. Anybody's worked in C and they understand you've got your stack, your heap, your statics, your code area. Rust is the same model. So at the raw machine level, it's identical to C and C++ in that concept with them. It's a heap-based language, but you're still responsible for the language. It's closer probably to modern C++ in many ways than it is to C. But it does one thing uniquely, something that no other language I know does, which is lifetime management. And it does it at compilation time. And that's still one of the biggest potential sources of runtime errors in programming when you've got to manage it yourself. And that's the beauty of the JavaScripts and the Pythons, is a lot of that lifetime management is done by the language because it's doing in the background the garbage collection and memory management. Where with C and C++, you have to do it as a programmer. And that's why in the deeply embedded, we ban a lot of dynamic memory, because it eliminates all of that category of runtime errors associated with it. But Rust has this unique feature that C can't do, C++ can't do, which is this lifetime management. The downside of Rust is that the learning curve is quite frightening. You sort of have to know the whole language to almost write Hello World, which is a bit of a barrier. But if you're a software engineer, you'll love it. Microsoft see interest in it. Obviously, it's come out of Mozilla. It can do all the web stuff. It can do, you know, WebAssembly. People running on Cortex-M systems. It's got that breadth without the baggage of C++. A simple idea they have is this concept called unsafe. So you can, if you want to do raw memory management using C, equivalent of C pointers, you can do it, but you have to wrap it in a block called unsafe, because you're basically saying the compiler cannot check these things for me. I'm taking responsibility of this, so I can use that. And it's those sorts of little ideas where we're saying, okay, we can still do everything we want to do in C in Rust if we wanted to, as we obviously can do in C++.
Has the art of coding actually gone away with these languages that are almost cut and paste now, where you just go into some server somewhere and pulling down code and just making it fit? Do people actually do real coding anymore?
And we talk about Stack Overflow programming.
Right.
we still do see a lot of that. And I don't think the coding's going away. I mean, we've talked about visual programming for years. I remember when I started back in the 80s, you know, and there was Jackson structured programming, good old JSP was going to lead the way. And then UML, of course, is just not precise enough. You know, you've got the MATLabs, you've got the Lab4Us, they've got a very good niche in that area. But you look at the hardware guys, why are they doing, you know, System Verilog or VHDL? They've almost gone back to programming because it's still the most, from a productivity perspective, it still massively outweighs doing it visually in that sense. And I think we just haven't got the programming model that is easy and to use and scales, especially to non-trivial systems where you could do it visually and you could move away from hands-on programming, writing that particular code. And we shouldn't forget what Barry Beam said in the 70s. People enjoy it. You know, it's the fun bit of what we do actually is the coding. And we don't want to tell anybody that because we get paid to do it. But coding is still the fun bit, you know, of everything we do in all this. And I think that's a motivation. And we shouldn't forget we're solving problems. You know, that's part of what makes you an engineer is you enjoy problem solving and writing code. You've not got physical constraints like you have in the electronics world and the mechanical world. It's purely your imagination in terms of solving problems. That creativity is what makes coding fun. So I don't think it's going to go away. And I don't think that level of coding, you know, in terms of people coming up with new ways of fixing things is going to change anytime soon.
Not
Because the
necessarily
language
better ways, but new ways.
new way, yeah, new ways, and that, I mean, that's down to languages. I mean, there seems to be a new language every week. I sort of keep a track on them, but it's the ones that are going to make it into mainstream. Going back to Rust, it'll be interesting whether it can make it over the what is it, you know, the good old tipping point, as they call it. Can it actually really get a foothold in the industry? And you look at what modern C++ is doing, and they're doing, I love what they've done with the language. You know, 17, 20, the language is actually getting easier to use compared to, you know, C++ 03 or 98. When we teach it now, it's a much easier language to teach now. So people who coming to C++ now from C, it's actually better if they don't know any C++, because we teach in a totally different way to how we used to teach C++, because it's closer to Python. You know, it's closer to, you know, JavaScript. It's closer to Swift or Go or all those sorts of modern day expectations of language structures you would want, which we just don't have in C, and we will never have it, I don't think. Why do we still use C? The nearest analogy is it's like chef's knives. You know, professional chefs, they have their own set of knives they carry around from job to job because they're incredibly sharp. Any normal person will cut their fingers off with it. So the right tool in the right hands can be an incredible thing. But the problem with C, you know, as we say, it's easy to learn but difficult to master. And there's a lot of people who know the language but certainly haven't mastered the language.
I hate to knock us out of the fun part of the discussion about software engineering and creativity, but part of the point of this is the cost of optimizing your code for a given embedded target. There's all these PICs out there. There's still AVRs. There are all these different ARM cores. And the entire point of embedded engineering is that you're spending time making sure that your code is going to run efficiently and most cost effectively on that given target. So just turn that on its head, forget all of those little micros. Let's just use an Atom processor, and then we can write in Java or C++ or Rust or whatever, and we don't need C at all, right?
How do you measure cost of software?
Well, by how many hours you're sitting at your desk using your imagination.
But do we? Does any company actually measure software costs? Define software quality? I mean, hardware is easy. We can measure the cost of hardware, and that's very compelling, as you say. You know, I think one of the biggest things that changes is when you move to, and we've seen it with Linux, you know, the growth of Linux and the growth of Android, is that massive jump when you start having a memory management unit. Well, again, internally, we talk about deeply embedded and embedded. And embedded typically means you've got a memory management unit, an MMU, so you can run Linux. And everything else is deeply embedded. Whatever you say, that is the Rubicon of the change, because once you've got the MMU, you've got a potential of a process model. And that suddenly opens up all those things. It opens up Linux, it opens up Android, it opens up all these other languages that are built on top of that more general purpose operating system. So that's the biggest choice you make. But unfortunately, companies don't. I mean, I'm working with a company recently who are currently using a Cortex-M, and I'm a big fan. I've always been a big fan of the Cortex-M because they're a software-friendly processor. When they designed the core, they thought about software. You can see aspects in the instruction set. You can see aspects of the design of the actual chip. Makes it easy to write software for. I've never felt that about PIC personally. That's just a history thing of coming from that background. So they've been using that successfully. They're looking at going back to a PIC just because of the cost, the bill of materials. I sort of go, why would you take that step backwards when you've made that jump forward and you've got this whole opportunity? But at the moment, certainly manufacturing, cost is king. You know, bill of materials is still drives it. You look at the automotive industry, most companies are still measuring the cost of resistors. While bill of materials wins, software's free. It doesn't cost anything. That's
not true.
I know it's not true, but go and talk to the senior management in most of these companies and they think everything's free because it's only the cost of people. And It's a different accounting system. You know, you look at the cost of some of the hardware tools, what the hardware guys will pay for the Synopsys and, you know, the Mentor tools, and they'll pay hundreds of thousands of dollars for those tools. Try and get a company to just pay a couple of $1,000s for a compiler. And they're going, but they're free ones out there. Why aren't you using all the free stuff? So it's that mentality. We don't measure software quality. We don't have a cost factor for software quality. So we don't measure software. So we can't cost it. So it's free. I don't think it's going to change anytime soon, just because until we truly can cost software, the only cost of software is how much processor power do you need and how much memory do you need. We don't even measure the cost of maintenance, software updates in this system. So I still think that's the root of the thing. Until there is a realistic cost model, hardware will always dominate. Bill of materials will dominate in this industry, in the deeply embedded space.
Going to put you on the spot. Niall Cooling says it in 2020. When does C go legacy? A, 5 to 10 years. B, 10 to 20 years. C, 20 to 30 years. D, never.
I would be really surprised in 10 years we look back, C still isn't a major player in this industry. The things that are going to affect it are going to be hardware step changes, things like RAM memory, etc., coming through, whether we get a change in the memory architectures we've got that can improve power and can improve, obviously, persistence. Battery technology, I think, is going to make a massive difference. If we get some breakthroughs in battery technology, that would make a difference, because then, of course, you can have more powerful processors because you can afford to be less power sensitive in the sense within that. But without those, I don't think it's going to change anytime soon. The Rust community talk about, it's going to kill C, it's going to take over. It's not. I think it can be a third pillar of embedded languages. The problem is modern C++ is there's a perception of it being too complex. It's not, but there's this perception because it was within that. So I think that's going to struggle to get more traction. But C's just easy, and I think that for so many companies who are not, well, they don't realize they're software companies, C is the path of least resistance. And that's what it is. I mean, it does come to that. It's the easiest way to get software into a system is using C. It's not necessarily the best model, but it's the easiest model and the most perceived to be the most cost efficient model to do that, because it's not an issue getting C programmers.
Niall says D, never.
The C community, I always say they're backward looking. They're always looking at legacy because they've got decades and decades worth of stuff. Where the C++ are finally woken saying, if we're going to survive as a language with all these new ones, the Go's and the Swifts and the Kotlins and the Pythons coming along, if we're going to continue as a language, we've got to satisfy the needs of the younger generation coming out of college who want to use these new sexy languages with all these features like Landers, etc. And we've suddenly got them. We've now got them in modern C++, etc., and in Rust, etc. And again, it's interesting that Rust has got concurrency, threading in the language from first principles. It's not being added to the language. It was built into the language from day one, as Ada was. So that has an effect on many aspects to do with the way the language is going to work in those things.
Now it's time for Tech Market Madness with guest Chris Ramel, Executive Vice President of VDC Research. What does your latest research show in terms of embedded or IoT language distribution?
So probably no surprise to you all, it is a polyglot world out there. Obviously, there are the languages that are very common like C, but there's a ton out there that are used, some of it's different purposes, but many times, obviously, on the same project, you have people using a number of different languages. And it's much more diverse in terms of that landscape than it was when I first started looking at this space 13 years ago. At that point, when we were doing some surveys on this space about programming language choice, C was stated as being used by 85, 90% in that range of embedded developers. Now you're looking at rates that are on current projects that are about half that. And no real surprise there, except for maybe the length of the decline. What's become adopted more over the years, you've seen object-oriented programming generally gain more and more use. So C++ and Java, among others, and then more scripting languages too. So JavaScript, but also Node.js. Rust has started to gain some adoption the past couple of years, as well as people using Python for more and more purposes as well. But again, you still have that undercurrent or base level of people using C or even just assembly as well.
Do you think this is because C engineers are starting to age out?
No, so maybe a parallel anecdote. I remember years ago, I was talking to someone at an aerospace engineering firm, and the conversation went to talking about the Ada dinosaurs, all the programming that was used in that space with Ada, given its benefits in the safety critical market. And they talked about the need to train people up. And certainly there were those long-standing institutional experts, but it was still something that is very much part of the needs for that institution. I actually have a brother as well that's an engineer for the DoD. And when he was first starting there, that was something that he had to ramp up on, having done in university mostly, Java and C and such.
What are some of the apps that some of these languages are being used on, like Rust or Python today?
Really, you have it in a wide range of applications. It's no surprise that if we look at some of the more consumer-facing applications, you see more object-oriented use, and it's more a correlation based on the needs of some of the other industries where you see a larger and more inelastic use of older languages like C or even Ada as an example, which is still pretty widely used in like A&D among some other industries. Automotive and vehicle is a place, for example, where C remains very widely used. They're not the same needs that might drive someone towards some of these other languages. As you start to look at some of the places with faster rates of code growth or the integration of more connectivity or things that start to look a little bit more like kind of enterprise IT, that's where you start to see more of the bleeding over of some of these other languages, where the boundaries have blurred between kind of the traditional embedded or IoT space and what people might be doing in their data center, as well as the just access to that labor pool where those skill sets are more and more relevant to some of those systems that have screens and that are connected to kind of systems of systems and other broader deployments.
What do you see as the growth of these languages over the next 5 to 10 years?
I think that you're going to continue to see people looking at languages like Rust or Node.js or others that offer organizations another tool in the toolbox. Just as I noted, you never really see languages completely disappear. Whether or not you're looking at organizations trying to leverage all of the IP that they have in prior projects or tap into the skill sets that they have in their existing engineering and developer pool. But you're going to continue to see that some of those languages that have gained traction and proven themselves in the enterprise IT and broader ISV space infiltrate the engineering markets in greater frequency. So I don't think anything is going to change or disrupt that trend, aside from it being a requisite for many traditional embedded engineers, quote unquote, to wear more and more hats and be familiar with a wider set of languages than maybe they once were.
What's the name of the report where our listeners can find out more?
Our most recent Voice of the Engineer report at vdcresearch.com highlights some survey results from almost 800 respondents. And this is a set of research we've been doing annually for actually about 20 years at this point.
Thanks for listening to this edition of the Embedded Insiders. For daily industry news, videos, and podcasts, visit our website, embeddedcomputing.com.